In the last video, I showed you how to download a station description file from the DWD Climate Data Center, providing information on climate station measuring precipitation. Now I will show you, so after we downloaded the file, we converted this fixed width format into a CSV file, a comma separate value file. And now I will show you how you can load this information into QGIS, the Geographical Information System we are using, and how to generate a layer from that. First of all, install QGIS. So it's written QGIS. The URL is .org, qgis.org. And so currently they are providing two versions, 3.16, which is feature-rich, and 3.10.11, it's long-term release. So I'll go for the LTR version because this is probably less buggy, but also less feature-rich. So I download here. So I go for the standalone installer from OSGeo4W package. And in my case, it's Windows, and I use the 3.10 version here, 64-bit for my Windows. But you also have, of course, distributions running on Mac OS and Linux, and even on BSD and on mobiles and tablets. I think that might be an Android. I've never used that, so I stick with the Windows version. So you download it and install it, and so I did that beforehand, and I can open QGIS from the launcher OSGeo 4W. No, that's the wrong here, sorry, QGIS 3.10, and I open the QGIS desktop 3.10 without GRAS. First of all, just the desktop version of QGIS. It takes some time. It's on my other screen. I cannot move the splash screen to the screen I'm sharing with you, so we just have to wait a bit. So now the system comes up, and we start a new project. So QGIS is a geographical information system, and so it's very powerful and open source, so many people are using it. And so I don't want to explain all the details for now, but just show you how we can add information from a text file to QGIS. I want to add a new layer, add a layer from a delimited text, add a delimited text layer. I go, so the file name, I browse to the directory, Geoinfo, temporary repo, DWD climate stations. And now that's the one we generated in one of the last videos, hourly, precipitation, recent, and this CSV file. That's the one we created. Öffnen, open. So the layer name by default is the file name. We can change it if we want, but that's okay. So it will be added to a new layer. This information will be reflected in a layer. So then we have to explain the file format. So let's have a look at the file first of all. I think it still might be here. Yeah, it's still here. So this is the file we created with Python. So the first row contains column headers, and we have geographical information in the columns latitude and longitude. And you see that the field separator is a semicolon, and that's basically all we have to know. So latitude and longitude. So let's go back to QGIS here. So it's a custom delimiter, otherwise it would use a comma only. It's a semicolon. And it automatically detects some magic, right? So it finds the column longitude and assigns it to the x coordinate. And the latitude, so north, that's latitude direction is north-south direction, longitude is east-west direction. So usually on a map, it is, so the longitude goes from left to right, that's the x field, and the y field is the latitude. So we have to give a geometry coordinate reference system. The geometry which is encoded here, these are points in space, right? Have of course a certain coordinate system. So what does this number, let's go back here to the file and have a look. What does this number, let's say 50.78 to 7, what does that mean, right? So we have to give a unit to it or a coordinate reference. And in this case, it is degree and the coordinate, and there's many different coordinate reference systems. And but this one here, which is used, is the WGS 84. It's pretty much a standard, and it has the EPSG number 4326. So you have to choose this yourself, and there are really literally hundreds of different coordinate systems. And the EPSG is a, let's say, standardization or standard which assigns unique numbers, a unique identifier to all the different coordinate systems which exist. Okay, I think that's pretty much what we need. So the x field is automatically assigned, or the column longitude is assigned for the x field, and the latitude here is automatically assigned to the y field. Say add and close. So this is now the distribution of the stations in that particular file for hourly values of precipitation. We don't know if all these stations are still active, but we will find out. So first of all, we see here that this is now arranged in a so-called layer. So we can activate a layer and deactivate a layer for printing. We can, and the most important thing now is we can select or get info from a station. For example, this point here. I can click on this here, and what you now see is that the station ID is of this particular point is 2629, date from, date to, altitude, latitude, longitude, and the name is Kleve. You see, this is the station in Kleve, and date 2 is today. That means the precipitation measurements in hourly resolution are still active in Kleve. So what's then this one here? This station here is Xanten, and that also is still active. So you see Xanten. This here is Geldern-Walbeck, and that one here is already Bocholt, and so on. So you can get information here. So that means these points are also called features, and these features, or such a map object is a feature. It has a geometry. In this case, it's a point. And associated with this geometry is our attributes, attribute data. And how can we access that attribute data? We right-click here on the layer entry and open the attribute table. And then you see the different attributes like station ID, date from, date to, altitude, latitude, longitude, name, and state. So even here we still have latitude and longitude as features, or sorry, as attributes in the attribute table. But at the same time, while we imported this spreadsheet data, this CSV file into QGIS, latitude and longitude have been assigned to geographic coordinates, and points, a point geometry has been generated from latitude and longitude according to that specific coordinate reference system. So what happened now while we uploaded the CSV file or loaded the CSV file or imported, basically it was an import. We imported the CSV file to QGIS was first X and Y columns had to be assigned. The information had been used to create a point cloud, you can say in this case, right? A point layer geometry. And at the same time, these points are then associated with the according information here, which are the attributes. Okay, we can also select, this is just the info button here, right? But we can also select features individually or with a rectangular selection. Let's say we want to select these 3 points here, then the color changes to yellow. So these are now 5 selected points probably. We open the attribute table, right click on the layer, open attribute table, and when you scroll down, you will see that some of these rows here are selected. Let me do that again because I want to operate in my, so to unselect, we select simply an empty area with no features. I want to go further southwest in the region where our university also resides. The Rhein-Waal University is in the county of Kleve and Wesel. So I'm selecting, and there, this is close to the Dutch border. So we basically don't have any visual reference here, so we don't really see where these points are, but I will come to this a little later. So we have now here the 4 points selected. Go here, open attribute table. You see that some of them are selected. So here's one in Xanten, for example. That's the place I live. And now we can sort the table according to the selection. Move the selection to top. So we move the selection to top. And you see here Geldern, Walbeck, Kleve, Xanten, and Bocholt. These are these 4 points here. And each individual point, shape, or feature, basically it's a feature. Each of these features has a geometry. In this case, it's a point, but it could also be a polygon or something else. So it has a geometry, it's a point. And this feature not only has a geometry, but also an attribute set. Good. So now let us add some more information to really see where we are, and we want to limit the further analysis to the stations in the federal state of North Rhine-Westphalia. So we need boundaries for the federal state of North Rhine-Westphalia. And how do we get them? We have, so if you Google, so you can Google for the term digitale Verwaltungsgrenzen, NRW. So these are the official digital administrative boundaries. Digitale Verwaltungsgrenzen, NRW. So North Rhine-Westphalia digital administrative boundaries. So when you search for that, for this term, you come to Bezrec-Köln. This is it's the Bezirksregierung as in Köln, and Bezirksregierung is county administration, or so the federal state itself is separated. So North Rhine-Westphalia is separated in 5 districts, and this is the district administration. And the district administration of the district of Cologne provides open data for the federal state of North Rhine-Westphalia. So digitale Verwaltungsgrenzen, digital. So we can translate that here in Google to English, digital administrative borders. And so here you see the product description. So please read this, right? For the state of North Rhine-Westphalia, administrative boundaries in the form of closed polygons as vector and raster data in 2 levels of detail are derived from the basic landscape model, DLM. Okay. Good. So the district government of Cologne. Bezirksregierung Köln is district government. So what's the georeferencing? So the coordinate system used for this so the basic coordinate system used for this for the boundaries, for the administrative boundaries, is EPSG number 25832. So let's have a look what that is. EPSG 25832. And here is a website showing all the coordinate systems, coordinate reference systems, which are part of the EPSG standard, so which are described by EPSG. So you see, this is universal transverse Mercator projection. I will explain this in another lecture what that is. Zone 32 North. And so it's Europe onshore and offshore. And you see this also covers here Germany pretty well. And therefore, the federal state of North Rhine-Westphalia decided to use this coordinate reference system as a standard, as its standard coordinate reference system, ETRS 89, which is a UTM, a universal transverse Mercator projection of the 32nd stripe. And that's something I will explain later. So then the position accuracy, so that means the boundaries now are encoded in polygons. So they are stored as polygons. And the question is, what is the resolution of the polygon? And the position, so we have position accuracies so we have 2 different data sets with different position accuracies, and DWG1, Deutsche Verwaltungsgrenzen 1, so German administrative boundaries, 1 is ±3 meters, and DWG2 is ±50 meters. So it really depends on which scale you are operating and from which distance you are looking at it. Okay, so then we have different layers. One layer is GEM, which means Gemeinde. That's the boundary of the boundaries of the municipalities. A Gemeinde is a municipality. Then we have Kreis, so that's Google translated is, but Kreis is the boundary of a county. So this is a mistranslation by Google. So here in German you would read Kreis, and that's a county. Then we have the boundaries of the administrative districts, Regierungsbezirk, so the district, the different districts in North Rhine-Westphalia, so we have 5 of them, and an RW is the border of North Rhine-Westphalia itself. Okay, DWG1, administrative boundaries with all boundary points from the ATKIS basis DLM, so that's the basic, the fundamental underlying information, and this data here provided by Bezirksregierung Köln is now derived or extracted from this base data set, you can say. So then we have web services. So whatever we is provided here can also be added as a web service. That is a kind of online map, you can say. You can add this to your QGIS project, for example, which is then running in the background. For example, Google Maps or Bing, these are web mapping services which you can just include or use in your projects without storing the information locally. So, and they are updated when you are changing, for example, the map and moving it, zooming into it, and so on. Then automatically the web mapping service would provide the new information, but we will come to this in another video. So then we have raster data, conditions, node of fees, and so on. So we go for DWG1, raster and vector data, OpenGeo data NRW. So let's download that. Download. So again, metadata, right? It's translated. License, Germany 0 version 2. I don't know this license, but it's free of charge at least. And it's open data. Coordinate reference, record description, and user information PDF. Let's open this one and see what that is. Repo. It's not really related to any of these projects, so yeah, I just, for now, I store it here. Show in folder. So this is now in German. You should use then Google Translate to translate it to English, but I just want to see what this is. Okay, it basically describes again the data set. That's what we've seen before. Like, as you can see, Gemeinde is county. No, it's like a city or municipality. Gemeinde is municipality. Kreis is county. Regierungsbezirk is district. Bundesland is federal state. Nordrhein-Westfalen, and so on. And then the accuracy, coordinate, and so on. Yeah, okay. And how this is derived and which different file formats. You see, these are data formats, and the one we will use is the so-called shapefile. But the shape data format, we sometimes say shapefile, but in fact it's a set of at least 3 files. Sometimes we have 5 different files. But the collection of these files with the same file name is then denoted as a shape file. So basically, a shape file is not just the SHP, but SHP and SHX and DBF. So that's the geometry file, that's a spatial index file, and this file here, the DBF, holds the attribute data. We will see how to work with that stuff. Okay, so far so good. So let's download the stuff. Okay, shape. Repo. I want to use this here for the climate stations, basically, maybe somewhere here in data, and then DWG, Deutsche Verwaltungsgrenzen, I call this for now DWG1, but I could also call it Bezirksregierung Köln or county or district, not county. Open in folder. So now extract. First of all, I go into the directory, I change into the zipped archive, so it's a compressed file set. And when I change into it, I see that there is no additional directory holding all these files. Therefore, what I do now is extract files to a directory called a folder DWG1 and so on. So otherwise I would completely mess up here my directory. So when we change here, we see now, let's, for example, use this set of files. You see dwg1 bld_nw. Deutsche Verwaltungsgrenzen, Set 1, so 3 meters resolution, BLD is Bundesland, NW means North Rhine-Westphalia. So German administrative boundaries, 3-meter resolution, the federal state of North Rhine-Westphalia. And here you see the 5 files belonging to the shape format, or sometimes we say shape file, but that confuses. It's a bit confusing because this SHP file alone is also called a shape file, but basically it's nothing without this additional information. So you always need an SHP together with some other information. Good. So this would now be the boundary of our federal state. So let's go back to QGIS and import that now. And we say we want to add a layer, add layer. And polygons and points are vector data. So a polygon is a set of points together with edges, and the point is of course a point, and they have coordinates x and y, and sometimes x, y, and z. And so they can be seen as elements in a vector space. Therefore, this is a vector data format. And now we are adding a vector layer. Go here. Data, Deutsche Verwaltungsgrenzen 1, EPSG 25800 and I don't know what. So, and then we have to select this SHP file, but that would also load all the other files. So, öffnen, open, and add. So you can change the source type, file, directory, database. But this is now really a file. Add, close. So, okay, now we have another layer, another information, but you see that this is not really, so the projection, first of all, is not really nice because the natural coordinate system for Germany is not EPSG 4326, but EPSG 25832. This one. See here also a zoom. And so now we are changing the coordinate system here. The current coordinate reference system, CRS, is coordinate reference system, is WGS 84, and we are changing this now to EPSG 25832. Okay. So now this looks more like a German map. But what now happened is you see that also the points have changed their position on this plot, right? On the canvas where we draw the map. You see that this looks different from what we had before. That means that also these points are now automatically reprojected from one coordinate reference system to the other coordinate reference system. So what I want to say here is when we imported this information, right? You remember we imported that, and then we had to choose from the so we imported the CSV file, and we had to choose the coordinate reference system of the data in that CSV file. Because QGIS doesn't know when there is a 51 somewhere in a column. It doesn't know, is it meters or is it degrees or what is it? So is it what kind of number is it? What is the coordinate reference system? And we had to tell the system the coordinate reference system is for that data in the CSV file, the WGS 84, EPSG 4326. Okay, so that is now the inherent coordinate system of the data. the coordinate system of the natural coordinate system of the DWG1 BLD NW is EPSG 25832. This is not a big problem. You see, the data here is provided or stored in two different coordinate systems, but QGIS is capable of reprojecting, so converting information from one coordinate system to another coordinate system on the fly. That's what it does here. Okay, so you see now this is now the federal state, and unfortunately you see this polygon. We see now, let's zoom in, so we can zoom in here. It really, oops, I didn't want to select. I still had the selection active here. I wanted to move. And now you see the resolution here at the boundary of the polygon, and you see here is a point, and here's a point, and here's a point, and there, and you see that the point that the polygon is made of points with edges in between, and this polygon now, and the accuracy of the points is 3 meters, and the polygon now is also a feature. Now this is a polygon feature. It has a geometry, and it definitely has attributes. So let's have a look at the attribute table. Right click here, open the attribute table of that polygon. And you see we just have one polygon, and then we have the field GN, whatever that means, Nordrhein-Westfalen, that's the name of the federal state. And that's the current, the timestamp for the data. So when has it been updated or approved the last time? So that was in March this year. Okay, so now we can change the order of, let's say, displaying. So I can click on the layer and drag it down, and then you see that now the points are printed on top of the polygon, right? But we can also now activate and deactivate the polygon or the points and so on. We can create labels here and create maps, but that's also another exercise later. Let's have a look at some other information which we have in the data set we downloaded in the DWG1 BLD DWG1 data set. So let's add more layers, add another layer, add a vector layer. Which one now? Let's say Gemeinden, so that's basically the cities and villages, so municipalities, and these are the counties. So let's go for the counties. Okay, Kreise. Add, close. Okay, nice, isn't it? So this is Nordrhein-Westfalen. The Dutch border is here, and this tip here that's quite prominent, and that's quite unique for the county of Kleve. So when I go to this info button, click here, and you see this is Kleve. That one here is Wesel. This is Viersen, and I assume this is Duisburg. Oh no, this is Krefeld, of course. Mülheim an der Ruhr. Where's the city of Duisburg? Oberhausen. Ah. Okay. Düsseldorf. Duisburg here, sorry. Duisburg. Good, we can also search for Duisburg. Can go to the property table, open attribute table, and search here for Duisburg. And there's also a way to create a query and search for certain strings or so, but we can select it here as well in the attribute table. And if you change now to the map, you see that this is now selected, or let's say select Wesel. This is Wesel, and there's Kleve, or we can do it the other way around. I select Kleve here. This here should be Kleve. And if I go to the attribute table, then you see also here that the attribute, that the data set for this particular polygon is now selected. And then we can do all kinds of interesting analyses with these things. And of course, here again, the order, the printing order is not really cool. So we should definitely move the station file on top, the station layer on top of all other layers. And you see we have now two measurement stations, the meteorological stations measuring precipitation in Kleve, and here are two in Wesel. This one here is Duisburg, right? That was Duisburg here. Yeah. Okay. Right, okay, so that's what I wanted to show you. So what we have learned here is we learned how to import comma-separated value data, CSV files, with coordinates. When they have coordinates, we can create a point map from it, and we used the DWD meteorological station file, which we created ourselves from the FTP archive from the DWD with Python. And then I showed you how you can find the geometric information of the German administrative boundaries for the federal state of North Rhine-Westphalia at Bezirksregierung Köln, so district government of Köln. I showed you how you can import the so-called shapefiles, and a shapefile is not just one file but a set of files. For example, the attribute table here of each layer is stored in a DBF file. It's not in the SHP file. I showed you how to select either from the attribute table or from the map and how they are linked. And I also showed you how you can change the order of plotting in the map. Okay, thank you so much.